Hello, I'm Etyene Schnurr, Scientific Advisor at Ceramics and Biological Dentistry Foundation. Today we will talk about low temperature degradation of zirconia. But let's start first with some definitions. In nature, zircon occurs in combination with oxide silicate in the form of a crystal, like this here in this picture. If you separate just the element zirconium, you find its description on the periodical table, but not in nature. That must be associated with two oxygen atoms as a free oxide, zirconium dioxide, also known as zirconia. Due to zirconia properties, it is widely used in industrial applications and the pure zirconia powder in the development of medical devices such as dental and orthopedic ceramic implants. Zirconia is a polymorph material and occurs in three different forms: cubic, tetragonal, and monoclinic form. The low temperature degradation, or LTD, is a phenomenon that can occur with some kinds of zirconia. At around 200 to 400 degrees Celsius, the process known as phase transformation changes the stable tetragonal form of zirconia to the monoclinic form with a volume increment of 3 to 4%. That leads to micro cracks, loss of strength, and durability. The zirconia cannot be used in the development of medical devices. For medical devices, zirconia must be stabilized with other elements, and the most common is the yttrium oxide. Another way to minimize the wear of zirconia is treating the surface of the implants, as an example, creating a passivation layer by sandblasting. Commercially, we found the tetragonal zirconia polymer, which has high hardness, high fracture strength as compared to the development earlier ATZ. Nowadays, we find also the zirconia toughed alumina, which has higher fracture strength. Zirconia is also known for its biocompatibility, and part of that is because it's not affected for aggressive oral environment. That means under low pH due to diet, fluorides, or inflammation, the surface of zirconia won't change and won't suffer corrosion. However, it is also possible that particles from the material dislodge from the implant and reach the surrounding tissues. Studies have shown that the size and the shape of these particles impact on the biocompatibility of the ceramic implants, and smaller particles are easier for the immune system to be eliminated. According to the ISO 13356, zirconia in medical use must have 99.9% of purity, high density and small uniform grain size, as well as undergo controlled manufacturing process. I have analyzed the SDS ceramic implant system, which met the criteria and was awarded with the Trusted Quality Mark from Clean Implant Foundation on both certifications on both production and manufacturer level. As a conclusion, for your safety and for the safety of your patient, it's always a good idea to ask your manufacturer and your supplier if the ceramic implant system that you are using meets the purity requirements. Thank you for your attention and see you next month.